Hi, this is Laura again, and here we are with the McDougall Little Geometry Book, Chapter 10. This is 10.4, Other Angle Relationships in Circles. We're going to jump right in and look at a theorem here. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Now, that's pretty simple. It's very similar to what we learned about inscribed angles. But what we need to pay attention to here is that when we look at this circle and we see that this is our angle and it's 130 degrees, then okay, the intercepting arc is 260. And over here, this angle is 50 degrees, so its intercepting arc is 100. And what we need to notice is math is full of different connections. And so when we look at these connections, we can see that what kind of angles are these? These are supplementary angles. So these both have to equal 180. Both angle 1 and angle 2 will equal 180. Also, we know that we have a full circle here. So the measures of these arcs will have to equal 360. So if this one is 260, then this one will have to be 100. Math, all about patterns, connections, stuff like that. Let's use this. Go ahead and try. Make sure that you pause, and I'll get you the answers in a moment. Okay, here are the answers. If line M is tangent to the circle, then what we know is same with inscribed angles. This is going to be 1/2, so the measure of angle 1 is 75 degrees. And here the same thing, but instead we're looking for the arc, and if the angle is 130 degrees, then the arc is going to be 260 degrees. Very, very straightforward, basic stuff here. Another one, a little bit more complicated. In the diagram below, BC is tangent. Find the blue arc. Now, in order to do that, you have to find X. So go ahead and give it a try. Pause the video, and we can come back in a moment. Okay, I'm going to give you the answers now. And here we can do this two ways. Since anytime we do halves of things, we can either divide by 2 or we can multiply the other side by 2. So if 9x plus 20 here is twice 5x, then we can either multiply the 5x by 2 or we can divide the 9x plus 20 by 2. In this case, I think it's easier to multiply the 5x by 2. We get 10x, so 10x equals 9x plus 20. And x equals 20. But we're not done, because it didn't say find x. It said find the measure of the angle CBCBD. So we take our 20, we plug it in to where the angle is at 5x, and we get 100 degrees. So the measure of angle CBD is 100 degrees, given what we have been given. Moving on. There are 3 places on a circle that lines can intersect. It can be on the circle. This is an inscribed angle, you might notice. And also inside the circle or outside the circle. All basic common sense. If something's going to intersect, it can be on it, in it, or outside of it. So here's the theorem. If 2 chords intersect in the interior of the circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angles. Oh my goodness, sometimes they use so many words. So basically, if it intersects inside, the angle is 1/2 the sum of the arcs. So if this is going to be 50 and this is going to be 50, you can add it together and get 100, which means the angles are going to be 50. Now, that is just a little bit too obvious. So in the next example, they're not going to be quite so straightforward because they won't be central angles. So here is example 3. You'll notice these are not central angles. The arcs have different measures. So go ahead and apply that theorem, and I'll give you the answer in a minute. Okay, here we go. If this is 106 and this is 174, the theorem says add them up and divide by 2, and what do we get? 140. So x is 140 degrees. Very basic. Another theorem. This one is a little bit more complicated, but not really. If a tangent and a secant, two tangents or two secants intersect in the exterior, so before we did the interior, we also have done on the circle, now interior, exterior, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So that just simply means we're going to subtract. We're going to take the major arc of 180 degrees and the minor of 80 degrees, and we're going to subtract, get 100 degrees. We're going to take half of that, and we know that the measure of angle 1 is 50 degrees. It doesn't matter if it's tangents, secants, or one of each. That's the process. So it becomes very simple. Let's use it. Here's an easy example for you. Find the values of x, knowing what we know now about tangents and secants. Pause now. Okay, I'm going to give you the answer. Here it comes. Okay. If we are finding x here in the first one, we subtract 200 minus x, see how it got a little tricky, equals 72. So all we have to do is do the regular algebra, multiply by 2 on both sides, because we subtract and we divide by 2. So we end up with 200 minus x equals 144. Then we subtract and we end up with x equals 56 degrees. Very straightforward. Here there is something else. It's a little bit more complicated because we have to figure out what this major arc is. And it's not hard to do that because all we have to do is take the full circle is 360. We're going to subtract the 92 degrees and we're going to get the rest of this circle. So now we know we can say 268 minus 92 divide by 2 equals x. Do the simple math and we end up with x equals 88 degrees. Let's move on. Now this one is a little bit odd, and sometimes you have to ask yourself, what do I know about circles that will help me with this? Because you got to think back to some of the other things that we have learned. Also, there is more than one way to solve this, so I will show you 2 ways. Go ahead and pause. It may take you a while to figure this one out, but think about right triangles and what are the rules for triangles that are inscribed in circles and stuff like that. Go ahead and pause. Okay, hopefully you've taken all the time you need to really try and get this right. And you're going to notice that there are 2 ways to deal with this. The first thing you have to remember is you're going to have to figure out what the angle is. It says from the peak. This is what the one we're looking at right here, from the peak. So we need to use sine. Sine is opposite over the hypotenuse, and you're going to have to figure out what that angle is. And if you do it with your calculator, you'll find out that that is 87.89 degrees. Well, we need all of this, so we're going to have to double that to 175.78. Then we have to use the theorem we just learned, and we're going to do the subtracting. We need this large part. Now remember before where we subtracted? This time we're going to subtract, but we don't know what this number is. So we're going to call that x for this small arc. This major arc then is going to be 360 minus x. And then we have to subtract x for the small arc equals what the angle is, which is 175.78. So then we just have to do the simple algebra, and from the peak, you will be able to see about 4 degrees because you should get about 4.22. Now you have to remember that sometimes it becomes a little bit off, depending on calculators and rounding and all of that. So that's why from the peak you can see about 4 degrees. Now that's one way to do this. The next way to do that is, and this is the one I thought of first, though the other one was the one in the book. If we use this angle to find out, it becomes a little bit simpler. So we still need to find angle CBD, or what we are going to see from here, so it would be this arc, but we don't have to use this particular angle. We could use angle A. If we do that, we will need cosine, which is the adjacent over the hypotenuse, and you do it the same way you do the other one, and you end up with this angle being 2.14 degrees. And since we need both of them, then it's going to be 4.28, which is still, from the peak, you can see about 4 degrees. So there are 2 ways to do that. And it's a good thing they said not drawn to scale, because it is not drawn to scale. All right, that is the last one. We are ready for the quick quiz. What do you know about the angles formed by an intersecting tangent and chord? When you see this, what do you know? We know that they are half the measure of their intercepting arc. We also know that these angles are supplementary, and we know that the arcs together will have to equal 360. Number 2. How do you find the measures of angles that intersect inside a circle? Pause and make sure that you get the answer correct before you hear mine, because here it comes. You have to add the arcs together and divide by 2. Number 3, how do you find the measures of angles that intersect outside a circle? Remember what that rule was? You're going to subtract the smaller from the larger, divide by 2. So we're adding, we're subtracting. Okay, there you have it. That is 10.4. I will see you for 10.5.